We begin in 1896. In Paris, physicist Henri Becquerel accidentally discovers during an experiment that uranium leaves a trace or darkens a photographic plate without any other light source. He concludes that uranium naturally emits a ray he calls uranique in French. In the following years, physicists Pierre and Marie Curie discover other elements that also naturally emit radiation. They call the phenomenon radioactivity. Later, Ernest Rutherford, a British physicist born in New Zealand, suggests that radioactivity is radiation that accompanies the disintegration of atoms, which were previously considered to be indestructible. Other findings are then used to better understand the structure of the atom, with electrons revolving around a nucleus composed of protons and neutrons. In 1938, two German chemists, Hahn and Strassmann, discover nuclear fission. Bombarding an atom of uranium with a neutron, it is divided into two, releasing energy. The following year in Paris, Frédéric Joliot-Curie discovers that during the nuclear fission of uranium, three neutrons are ejected, which in turn could cause further fission of atoms. He discovers the ability to initiate a chain reaction and thus produce a large amount of energy. In Europe, World War II breaks out. While Germany continues to conduct research on uranium, Albert Einstein is convinced by Hungarian physicists to sign a letter addressed to Roosevelt, the President of the United States, informing him of recent nuclear discoveries and the possibility of creating a very powerful bomb using uranium. The United States benefits from the influx of European scientists fleeing war and invests in research. At the University of California, Glenn Seaborg discovers that irradiated uranium produces a tiny amount of plutonium, a new metal that is radioactive and fissile. That is, it can trigger a chain reaction. In Chicago, Enrico Fermi creates the first atomic pile and for the first time manages to control the first chain reaction of the fission of uranium atoms. Research is accelerated and substantial resources are invested. The United States secretly launches the Manhattan Project in collaboration with Canada and the United Kingdom. Top scientists gather in about 30 secret locations with the best laboratories at the time made available to them. Their goal is to create the atomic bomb. The goal is to create a bomb from uranium and another from plutonium. In nature, uranium is composed of more than 99% of uranium-238, that is a nucleus of 92 protons and 146 neutrons, and 0.7% of uranium-235 with 3 neutrons less. Only the latter is fissile and therefore useful in the project. The challenge is isolating and concentrating it to obtain so-called enriched uranium. The United States manages to produce 64 tons of highly enriched uranium to be used in the manufacture of the first bomb. By propelling a highly enriched uranium block onto another, the material becomes supercritical. Fission begins, and in a split second, a chain reaction ensues, releasing tremendous amounts of energy. For a plutonium bomb, a maximum of uranium piles are created in order to collect the plutonium produced. A few pounds are concentrated in the center of the bomb. By simultaneously causing explosions all around, the material is compressed, becomes supercritical, and explodes. On 16 July 1945, the first successful nuclear test takes place in the desert of New Mexico. By this point, Germany had already surrendered. Only the Empire of Japan is still at war against the United States. After Japan refuses to surrender unconditionally, the United States drops 2 atomic bombs on the country, a uranium bomb on Hiroshima and a plutonium one on Nagasaki. The 2 bombs cause about 200,000 civilian casualties. Days later, Japan surrenders. With the United States demonstrating its power to the world, the USSR accelerates its own nuclear program to try and catch up. the USSR conducts its first nuclear test. During the Cold War, both powers engage in a frantic arms race. Large sums are spent to gain technological superiority and possess the world's largest nuclear arsenal with the ostensible aim of deterring the enemy from attacking. While the United Kingdom tests its first atomic bomb, the United States tests its first thermonuclear bomb, also known as the hydrogen or H-bomb. This is a fusion bomb, that is, it reproduces the reaction occurring in stars by fusing two light atoms, deuterium and tritium, under high pressure and a temperature of several million degrees Celsius. To achieve these conditions, it is decided to use the atomic bomb as a trigger. The explosion of the plutonium bomb creates the right conditions to trigger the fusion of atoms. The explosion that follows is far more powerful than nuclear fission. The Soviets in turn develop the H-bomb. In parallel, research is made to develop nuclear power. The first nuclear power plants appear. The majority of future reactors would be with pressurized water. In the core of the reactor is a vessel in which low-enriched uranium is placed and used as fuel. Chain reactions are controlled to last about 3 years. The heat emitted increases the temperature of pressurized water in the primary circuit. This circuit is brought into contact with the secondary circuit in which water heats to transform into steam. This is used to rotate the turbine, which is linked to a generator that produces electricity. A cooling circuit pumps water from a river or sea to cool the vapor in the secondary circuit. Sometimes cooling towers are built to cool the water in the last circuit. To encourage research in nuclear power, the International Atomic Energy Agency, or the IAEA, is created under the aegis of the United Nations. The organization is responsible for ensuring the safe and peaceful use of nuclear energy. In addition, nuclear would also be used in medicine, notably in medical imaging and the treatment of certain cancers. While France tests its first atomic bomb, the arms race between the USSR and the United States takes a turn for the worse. The two powers have already developed intercontinental missiles and nuclear submarines. The USSR conducts the most powerful test of the Tsar bomber with a capacity of 50 to 57 megatons of TNT. The following year, the US tests a hydrogen bomb at an altitude of 400 kilometers. The explosion creates an artificial aurora visible even from New Zealand, while the emitted radiation damages at least 8 satellites. The same year, while the United States threatens Soviet territories with nuclear missiles installed in Turkey and Italy, the USSR places in Cuba nuclear missiles pointed at the United States. Just as tensions build to a climax, negotiations take place between the two powers, after which both parties withdraw their missiles and the situation calms down. China tests its first atomic bomb. The United States and Soviet Union takes a dim view of the arrival of new competitors. Via the UN, they propose a treaty on the non-proliferation of nuclear weapons. This differentiates the 5 so-called nuclear powers from the rest of the world. Existing nuclear powers cannot share knowledge or supply weapons, while remaining countries cannot attempt to obtain the atomic bomb. In addition, nuclear powers are supposed to disarm as much as possible. This treaty would gradually be signed by all countries of the world with the exception of India, Pakistan and Israel, which denies having atomic weapons despite heavy suspicion of the contrary. Latin America goes further by creating the first populated area free of nuclear weapons. Finally, the United States and Soviet Union agree to limit the production of strategic weapons. 1973 sees the world's first oil crisis. In a short time, the price of a barrel of oil explodes, undermining global powers whose economy largely depends on the black gold. The world looks for alternatives to ensure their energy supply. France and Japan mainly rely on nuclear energy. In the following years, many power plants would be built around the world. In India, a so-called peaceful nuclear test takes place, worrying its Pakistani rival, which in turn embarks on nuclear research. In 1979, a major nuclear accident takes place in the United States. One of the reactors at the 3 Mile Island nuclear power plant surges and the primary circuit leaks. As the fuel is no longer submerged, it overheats and then melts in its vessel. Fortunately, the containment resists and prevents radioactive leaks. A few years later, at the Chernobyl nuclear power plant, after a series of human errors, technicians lose control of the reactor. When the temperature of its core becomes too high, an explosion blows up the concrete roof, part of which falls and fractures the vessel. A highly radioactive cloud is released into the air. It spreads and contaminates a large part of the European continent. Around the power plant, a 2,600 square kilometer exclusion zone is created and more than 200,000 people are displaced. Around the world, the accidents generate or strengthen popular opposition to nuclear power, which puts a heavy brake on the development of the industry. After the fall of the USSR and the end of the Cold War, the US and Russia continue to reduce their nuclear arsenals. In addition, after more than 2,000 official nuclear tests in the world, the Comprehensive Nuclear Test Ban Treaty, or the CTBT, is introduced. It does not enter into force because out of the 44 countries with nuclear reactors at the time, 3 do not sign it and 5 others sign but do not ratify it. 2 years later, India and Pakistan conduct a series of nuclear tests. Abdul Qadir Khan, considered the father of the Pakistani atomic bomb, acknowledges having developed a clandestine network originating in Dubai, which has been providing Libya, Iran, and North Korea with the plans and materials necessary to create an atomic bomb. North Korea, after withdrawing from the Treaty on the Non-Proliferation of Nuclear Weapons, now declares that it has carried out its first nuclear test. At the same time, Iran announces that it has successfully enriched uranium, which worries the international community. Israel, for its part, maintains ambiguity over its nuclear program. Many believe the country has dozens of atomic weapons, but the latter neither confirms nor denies reports to deter any potential enemy. One of the advantages of nuclear power is that it emits little carbon dioxide. However, it generates radioactive waste with a lifespan of up to several 100,000 years. While most of the waste has a lifespan of a few decades, current technologies do not offer a definitive solution for high-level, long-lived waste. Most countries rely on deep geological repositories to store nuclear waste more than 300 meters under the Earth's surface. On March 11, 2011, Japan suffers a triple disaster. After a 9.1 magnitude earthquake, the most violent ever recorded in the country, its coasts are hit by a powerful tsunami with a height of over 10 meters, affecting the Fukushima nuclear plant. Crashes prevent the cooling of the core of its reactors. Within days, 4 reactors explode, releasing a highly radioactive cloud that is blown towards the Pacific Ocean, reaching the North American continent and then spreading throughout the Northern Hemisphere. All 39 Japanese nuclear reactors are then shut down. In the aftermath, Germany announces a phasing out of nuclear power. Elsewhere, most nuclear countries review the safety of their plants. While 9 countries still have 16,000 nuclear bombs, at the UN, a treaty on the prohibition of nuclear weapons, which aims at the complete elimination of nuclear weapons, is voted by 122 countries. Only the Netherlands votes against, while Singapore abstains. But the vote is marked above all by the absence of many countries, including the nuclear powers and member countries of NATO. If the treaty is ratified by 50 countries, it will come into force. Today, 34 countries have already ratified it. In terms of nuclear power, 417 operating reactors produce just over 10% of the world's electricity. 46 reactors are under construction, including 10 in China, whose energy needs are increasing. Elsewhere in the world, the nuclear fleet is aging. 2/3 of global reactors are older than 30 years, out of their originally planned lifespan of 40 years. Their future dismantling promises to be costly. New generations of nuclear power plants struggle to meet the world's rising energy needs, while its construction suffers significant delays and additional costs. Meanwhile, 35 countries are collaborating around the International Thermonuclear Experimental Reactor, which is being carried out in France. The aim is to study the possibility of building nuclear fusion power plants over the long term. Its budget has already jumped from 5 to 19 billion euros. But if the project is successful, it could offer a new type of power plant that would produce a large amount of electricity with little raw material and very little radioactive waste.